3-7, solving system equations using Cramer's rule, and we're not going to do that. We're actually just going to focus on determinants in this lesson. It should be a short video. We're just going to focus on determinants. Cramer's rule, I'll probably talk about it for a second, but it's not the best way of doing anything, so we're going to skip it. Let's talk about what a determinant is. It's a special number all square matrices have. Every square matrix has a determinant. We use that number to solve lots of things. Let's say I give you a basic matrix here. A, B, C, D. If I want you to find a determinant of it, I could say find a determinant of it like this. Or I could write an absolute value. A, B, C, D. In that form, that also just means find a determinant. Now how do we do it? Well, for a 2x2, all we do is downward diagonal minus upward diagonal. Let's make it like this. We're going to do A minus BC. And that's how you find a determinant of a 2x2. That's the shortcut way of finding a determinant of a 2x2. But if you want to find a determinant of a 2x2, you want to find that special number that all square matrices have, you just do downward diagonal minus upward diagonal. Let's do a quick example, and then we'll do a few more. Alright, so if I gave you that, the determinant's going to be 8, 2 times 4, minus 3, or 5. And that's the determinant of a 2x2. Few more quick examples. Determinant of this, down minus up. Negative 6 times 8 minus negative 7 times 10. I get negative 48 plus 70, also known as 22. Over here, down minus up, I get negative 28 minus 45. About 72, negative 72. And that's all it is for a 2x2 determinant. That's all it is. Right here, down minus up, 3 times 2 minus 1 times 6. In this case, I get 6 minus 6, which is 0. And that's actually a special result. It means you have no inverse. And we'll talk about that more in the next video. But keep that in mind. It says no inverse. The matrix says no inverse. We'll talk more about that later. That's how you do a determinant of a 2x2. Just down minus up. Down diagonal minus up diagonal. How about a 3x3 and higher determinants? A couple things. A, B, C, D, E, F, G, H, I. I'm actually just using the calculator. We'll do an example of that in a second. The way you're supposed to do it, the proper way of doing it is, it's just convoluted, but what it is you pick a row or column, any row or column, and then they all have a cosine chart. A sine chart, we call that. Plus, minus, plus. This would be minus, plus, minus, plus, minus, plus. What you do is you pick a row or a column, anything you want actually, and you expand on it. In this case, let's say I picked the top row, and let's say I picked A. What you do is you cancel out that column and that row. If you look at what's left over, you have A times this little small 2x2. Then you can do the same thing to the next one. I'm going to circle my B, I'll cancel out its row and column. If you just don't look at the blue stuff, like what's left over, you have D, G, F, I. So you have negative B times D, F, G, I. And then finally you do the same thing to the last one. Circle this one, plus C. Cancel out its row and column. And you're left with the determinant of D, E, G, H. And what you see here is all this would be, do this little determinant, down minus up, times it by A. Do this little determinant, times it by negative B. Do this determinant, times it by C. And then that'll be your answer. That's how you do a determinant of a 3x3. That is the way you do it. And that's actually the same way you're supposed to do a 2x2. You're supposed to do a little sine chart, circle, cancel out. 7 times 4, negative 4, plus negative 5 times 9. You circle and cancel it out. And that's where we get the down minus up thing from. That's where it comes from. And by the way, this method also works for higher derivatives. If you want to do 3x3, 4x4, 5x5, you all do them the same way. It's just pick a row column, expand. You do more of it in linear algebra. Anyway, after all that, let's do an example on our calculator. Here's my calculator. This is the way we're going to do this. We're going to type this in. I'm going to go to matrix, second matrix. I'm going to go all the way to edit, so I can type my matrices in. This matrix is a 3x3. Type in all the values. I just went through, typed in all my values. Let's get out of this. I'm going to go back to my matrix. And remember how I mentioned this before, how this is where you select your matrix. There's my 3x3. This is where you enter in your matrix. Math is where you do all the applications. We're going to go to math. The very first one you see there is the determinant. That's the determinant function. Get that, select your matrix, and get an answer, negative 48. And that's how you determine a 3x3 with your calculator. It's doing the thing where it highlights a row, selects it, does a smaller determinant, but you get the answer, negative 48. That's it for determinants. 2x2, down minus up, very important. 3x3 and higher, just use your calculator. I mean, there's a method that does it, but we're just going to use your calculator. Let's go talk briefly about Cramer's rule. So we're not really going to use this, but it's something you probably should understand what it is. Cramer's rule is a way of solving system equations. Let's say I gave you quick system 2x plus 3y equals 4 and negative x plus 4y equals 5. And you want to solve this. You can do elimination substitution, you can do graphing. I'm going to show you a different way called Cramer's rule. Now, Cramer's rule is really 3 components. You need to find a determinant. Let's rewrite this. as a separate matrix. We're going to write this. We call this coefficient matrix. 2, 3, negative 1, 4, x and y, 4 and 5. This is our coefficient matrix. This is the coefficient of our x's, 2, negative 1. This is the coefficient of our y's, 3 and 4. And then we'll have x and y right here, and this will have our solutions or our answers right there. Cramer's rule really just say 3 things. You find a determinant of the coefficient matrix. 2, 3, negative 1, 4. In this case, it'll be 8 plus 3, 11. Down minus up. 2 times 4 minus 1 times negative 3, or 3 times negative 1. You get 11. And then we have to find 2 more determinants. For our x value, that's called determinant of x, what we're going to do is we're going to switch the x column with the answer column. It's been like this, 3 and 4. Then I'm going to switch the x column with the answer column. So instead of having x, I'm going to have 4 and 5. You can take the determinant of this, 16 minus 15, 1. We're going to do the same thing for dy. We're going to switch the y column with the answer column. My y column is going to be 4, 5. And then down minus up, 10 minus negative 4. I get 14. And then what's the final part of Cramer's rule? Well, very simple. If you want to find x, it's just dx over the determinant. If you want to find y, it's just dy over the determinant. For x, it's going to be 1 over 11. And our dy is going to be 14 over 11. And that's the answer. That's Cramer's rule. It's a little long. I think elimination will be a lot faster. In this case, it's fractions might help. And then when you get 3 by 3, this will be faster for 3 by 3, except for the fact that they find determinants of 3 by 3, and it takes forever. It's actually not that much faster. But I did want to show you Cramer's rule, so that's Cramer's rule. And that's how it works. It works the same thing for 3 by 3 and 4 by 4. You just do the same thing. You find a determinant, and then for each variable, you just switch that column with the answer column. Then you put that over the determinant, and you're good. There's Cramer's rule. That's a lesson.